How's it going, everyone? Eulia Gonzalez here again. Today, looking at the React performance, a course taught by Steve Kinney, head front-end engineer at Temporal, where the goal is to see how we can write React applications in the most performant way, therefore React components, therefore React applications. And for that, we take a look at the reusing logic with custom hooks. Is one of the last sections that we actually need to absorb from the learn model of React. This self-paced uh, book or learning what this self book this self got this self-paced learning process. When we're looking here at topics of React, like how you can describe the UI and then how you can add interactivity, and therefore all of the things that is behind the scenes as well as the inner mechanism, and how do you then you can manage your state as a way to make it match to the UI state and the UI change, as well as how you can manage your state as you scale, and how you can pass down data to different components. And therefore, when it comes to actually connect to external systems, how you can do that and what are the built-in tools that React provide to you. So for example, I use ref and use effects and when we can use them. So this today's video is take a quick look at this last section in the escape hatch as a way to recap that particular topic, and then finally understand this reusing logic with custom hook as a way to, well, understand and move on to the relevant parts of the course, which is reducing renderings. So we can see now in real actions how now Steve Kinney actually provide all of these techniques and hints when it comes to identify any performance issue. When you come up with some React problems, you know what to do. So because the course here promotes is this particular way of thinking, or this recipe when it comes to identify any performance bottlenecks in your React application, which is first take a look at the production build. If that was built with the production flag or the development flag, then if that was properly built, you take a look now at the components hierarchy and the states. So you start from then, and then you take a look now at the different memoization techniques or ways to catch re-renderings. So for example, I use memo and when to use memo and when you shouldn't use memo. So you might not need an effect or you might not need a memo. And also look at how you can now render conditional components and how to load those components on demand as you need it. So for example, using the suspense API, and if you are really in a pickle, then see how you can use use the defer values and use transition, and what are the things that now React libraries actually promote, or thanks to this reconciliation engine called React Fiber, what are the things that it unlock, and what is the aim of the React Fiber? What is the problem it solves? And that is that it make it suitable for React in areas like animations, layout, and gestures. So with that, that's what they now pushing the boundaries and to now provide is this ability to pause, resume, and stop the rendering context or the rendering, as well as how you can is defer is the how you can prioritize renderings and how you can now uh, rendering multiple times or rendering multiple things at the same time, concurrent rendering. So that's quite interesting. And now, especially here in the escape hatches, as a way to see how all of this fits together, especially with the effect and the use graph, where they say you shouldn't, most of your application logic shouldn't rely on these features, the application logic and data flow. So even though when you need, for example, to synchronize with an external system or uh, connect to a server or send message and receive messages from that, or perhaps you want to manipulate is the focus on an input or the play and pause of a player integrated or implemented outside of React. There's some built-in tools that React provide to cover specific needs, because at the end of the day, this tool was to solve Facebook problems, and most of us doesn't have that kind of problem. But in any case, we look at use effect, use ref, and the subtle difference between the state is that this doesn't trigger any re-rendering. This is a way of how you can store information without trigger re-rendering. And the most use case is when it comes to store timeout ID, or when it comes to store timeout ID, ref, and DOM elements. When it comes when it comes to store the timeout ID, DOM elements, and any other object that is not needed during GSX calculation. So the point of this is that we look at how can we use that, especially for counters and timers, very useful, as well as for access to the browser API to talk to inputs, for example, to know some of the property, for example, focus on that input or know the size of the dimension of that element. And when it comes to talk to external systems or to synchronize with external systems, what this use effect built-in tools allow us to do, which is run this side effects logic. And since the React component is made of two types of logics, whether it is the rendering logic, where it must be pure, and the events handle logic, which this is when you can perform these side effects. React now provides this particular hook as a way to now run any side effect caused by rendering itself. And this now fits at the end of the rendering mechanism, at the commit phase. So with all of that, we also look at how can we describe, or how can we describe an effect, and when you might not need an effect, when a state update and another state based on another state, you might not need an effect. But this is called as the runaway effect. The runaway. The runaway effect. And what they call this, desbocado. Mm-hmm. Okay, the runaway. Okay, the runaway effects. Okay. This is something that you're gonna find in a lot of code bases. Oh yeah, it is. Deal with that. And as we look at the way how you can describe your hook use effect particularly. By by default, this use effect will run after every commit phase. But because you don't want to do that, you pass an array of dependency that you're going to specify when these side effects we're going to run, and also a cleanup function. So in the development mode we have now is this mechanism, the strict mode tag, where now allows to prevent is some of the common gotchas in your components as well as in your effects by rerun your effects and re-render your components twice. So what does it mean is that when you're writing your effects in development mode, you should be aware of this cycle, setup, cleanup, and setup function or setup process. Anytime you're going to write that in development. In production, it only run is the setup function initially. So most of the time when you're writing your effects, it will fit into one of these patterns. Or either you are connecting to an external system or a widget, a non-React widget, or you want us to connect to an animation, synchronize with an animation, to an event handler, or to subscribe to an event. So for example, your web API is exposed certain events that you want to subscribe to that. That's when you use a particular hook called use external hook as a way to now synchronize with external data that React is not aware of, and make it aware of that. And they provide this nice little convenient hook. Again, to solve some of the most common problems in React, in Facebook. And also the most relevant, which is that of fetching. Most of the time you're gonna do this, and you need to deal with some kind of condition here. So for example, race conditions. Anytime a user is now typing in something and that array of dependencies is tied to that input, you want is to prevent some race condition here. So a way to send that data to the client. So that's where we use, for example, a debouncer for that. But in the case of React, we use the ignore flag as a way to now, when this set of function is run, we put it at false, and as long as the ignore is false, you're going to update the state. Whenever the dependency change, which is now passed through the life cycle, all right, where you have now initially when the component is mounted, then the life cycle of the component, you have now the mount, updates, and the unmount, where now in the component or in the effect, it passed through the effect, it runs the setup function first. Every time it updates, it's going to call the cleanup functions first with the old state, and then the setup function with the new states. And last but not least, at the end or when the component is mounted, your effect will run one last time with the cleanup functions. This is important because now we lay out the foundation of how can we handle these race conditions in front-end applications with React, which is not a trivial thing, especially data fetching or navigating, browser navigation. And also you need to handle if some other things that happen behind the scenes, which is the you need to handle is duplicate requests, because when the client or when the user navigate to a URL, the server pre-render that content, send that to the client, the client show the initial loading, and then the browser needs to fetch that GSX that now brings interactivity to the web page, only to realize that it needs to now then perform a request. So this is something that is not, this is not what you want. So You need to actually handle that case as well as catching the response, because anytime the component is unmounted and remounted, you need to actually call it. You don't have any way to store that data. That's what you have, for example, other libraries that we're going to mention before. And also the network waterfall, which is anytime you have all of these different uh, components that are calling different APIs, endpoints, each one of them actually perform a request. So if you have multiple components actually calling multiple endpoints, that is not feasible, and that will you will have a huge performance issue here. So you need to also handle all of these cases as well as the race condition. That's why we have frameworks like Next that is capable to handle that. Next, Remy Gatsby, or client-side data fetching and catching libraries like UWR, which is stale while revalidate, which is a technique of how you can now is by looking at the state of your application first, and then you send the response to the client to actually update the state in your application to keep your data sync. And and also you have is React Query, React Router 6.4, and so on. And another use case for the effects is when it comes to do that in analytics. So all of this particular process and things, okay, that we need to do is something that is that when you're writing an effect, okay, it's also important to know when you might not need an effect. So if you need to update another, if you need updating an state based on another state of props, you not need an effect. Recalculate that. And I think this is one of the calls that a lot of people actually are not aware of, because they're just learning in React like that, and they don't know how the makers actually what is the problem that they are solving with effects. And of course that you're going to see a lot of this code base with that particular issue. So that's one. Mm-hmm. That's one. And the other rule is that if that things work, do not touch it. Oh no, because you can cause these ripple effects on that, and that's why a lot of people actually making migrations to new frameworks, because they realize that they don't have control of that, and if you don't do that, it's like well, good luck with that. And all of the other people that were previously on that, they don't want to know anything about that. So you inherit is this huge, massive, gigantic problem. So you better pick your own problems, bro. That's all I'm gonna say. You better pick your own problems. Oh, totally, man. Absolutely, absolutely. You better know. You better pick your problems. That's gonna say. That's all what I'm gonna say. Okay, so on that, okay, because we look also is on the React that we can is if you need to catch expensive computation, use memo. If you need to partially update some states based on another state and other props, again, now recalculate them in the rendering logic. For data fetching, use the use fetch, as well as for synchronizing with external system, use this that particular hook that I mentioned before. The use external sync And when it comes to now chains of computations, do not use an effect. In fact, see if you can change the computation based on the state. See if you can do that inside of the event handler. And as part of to understand now how this effect mechanism works, we need to look at the life cycle and what is the end goal of this. So anytime you're gonna write an effect, this is part of a synchronization process. And they can do two things. Start synchronization something, and then later on stop that. And because of most of the time, when you're doing this, you're gonna put some logic inside of it or some reactive code inside of your effect, and they call reactive code because this is now code that going to perform based or we're gonna run based on an array of dependency, and those array of dependency, those dependency you can choose those dependency. They must be reactive as a way to tell now the hook, hey, this value actually change, and this is what is going to be used by the hook to read those data. So because in those cases when you don't need to actually tell to the linter or that you need to prove to the linter, hey, these dependencies that I'm going to put here, they are not part of the reactive dependency, you need to put that outside of your React components, because all of the props, states, and variables defined or values defined inside of the render logic, they are reactive. This is something interesting to know. And because sometimes when you're doing this, if you're not careful about this, sometimes your synchronization process can happen multiple times or even fall into an infinite loop. So when you need to actually is write your effects, okay, and you fall into one of these particular issues, ask yourself, do we need this effect? So you might not need an effect when you run that or when you write that. Or if you do, then can I split that effects or the logic inside of that? Is the logic inside of the effects are doing several unrelated things? Remember that each effect must represent is a single separate synchronization process. And how now from that uh, it comes to actually put that logic into a reusable file, aka into a custom hook. Uh, if, for example, your one is to mix is this reactive logic with an event handler, therefore you want is to now is act or trigger and a reactive logic based on an interactions, then you have now something called event uh, the effects event as a way to solve this particularly in a specific challenge there. So you define some sort of inner logic inside of your reactive uh, effects, okay, or inside of your reactive code. You want is to now trigger is a particularly event handlers, but you don't want to do that when the array of dependency change. You want to do that when you specify a particularly reactive values. So again, this is very narrow. This is some advanced stuff. They actually are in alpha, by the way. And the another thing is that don't put functions and objects inside of your array of dependency because they change over time anytime the React is recomputing, so you don't want to do that. And when it comes to find ways to removing your dependency, ask yourself a couple questions. does it need, is this logic needs to be in an effect? Can I move this logic to a event handler? And the other, uh, if these effects are doing several unrelated stuff, so you separate that into a uh, so you separate that into so you separate that into multiple use effects, into single separate use effects. So are we reading some states? Uh, yeah, are we reading some states to calculate the next state? That's when we use is the updater function. Hey, are we reading in some state inside of your event effect logics to calculate the next state? That's when you use this the updater function. Hey, do you want to read values without reacting to its change? That's when you use is the event effect. And last but not least is that does some reactive value change unintentionally? And you need to check is where you're going to put your reactive logic. Uh, so the other is now reusing logic with custom hooks. So the idea of looking at this is that because now most of the time, when we want is to, for example, fetch data from the user or keep track whenever the user is connected to a chat room, you might not find this, and then you need to create your own hook. That's why we have, for example, hooks like this, um, like a form hook, form hooks, React form hooks. For example, we also have is the React query, for example. Okay, as a way to now, the most common things that we ever do here, simple React forms validation, like this, which is something that it works from mobile as well as version 5, version 6. Okay. Exactly. Let's go and that kind of thing. React for control. And control form is that. In faster mounted and all of the things. So, but as you can see now, how a lot of these things actually joins together is because of that. It's because that they are now solving a specific problems, and they are good about that. You know, React hook for form state management and validation, web, and React Native. So this is the reason why actually, well, they have a lot of people actually are back in the support because they're solving is a tedious, monotonous task. And that is how can we now append that particular elements or to interact with a forms, and then we get the data from the forms in a way that doesn't cause any re-renders on all of the child components, on all of the input components, and therefore the other custom hooks is the React query, or you can also have is the use stale while revalidate, right? Which is for a data fetching. But as you can see here, you are now looking at how now you can abstract this particular logic into their own package as a way to solve a specific problems. And anytime you want to add a particular library, you need to ask yourself, what is the specific problem that this is solved? You know, what is this specific problem that we are solving? What is the trade-off of this? Uh, so yeah, so custom hooks sharing logic between components. This is especially useful when it comes to shared logic between components, using not only hooks or not only effects. Okay, uh, like so, because custom hooks let you share stateful logic, not state itself, as well. And the other is passing reactive values between hooks. When you're going to receive that data in your React hooks, for example, here, server in URL, you say, hey, this is create connection. You're gonna return is this object, like that, followed by disconnect and on, which is something interesting. And when you use this create connection object, once you pass a notification here, which is so fantastified, that's what you can do thing here. You can extract this use effect into own custom hooks and then pass down data to that custom component. So for example, in the use chat room, this is how you're going to receive that, and then you're going to return or you're going to perform is this particular side effect code, passing event handle to custom hook. This is something that is in development, it's in construction. Okay, and when to use custom hook as well, the when you need to actually is abstract that logic into its own separate custom hook. All right. So keep custom hook focused on concrete high-level use case. Avoid creating and using custom lifecycle hooks that are act as an alternative and convenience wrapper for the use effect. So don't pass any functions to that, at least not right now. Only passing some options for that because they're not working. It's passing event handlers to this custom hooks is something that is under construction. So far so good. Okay. And custom hook help you to migrate to better patterns, and there is more than one way to do this. So once now finally be able to describe this, and it is time to look at the reducing renderings from this course. Okay. And
so guess what's next? What could be next?
Yeah, I think there was
there's another branch on everyone's favorite game called pushing state down.
Yeah, I think that was a very interesting thing to do because this was a recap of the entire React docs, and it only took me like 2 months to actually not only remember each one of those topics, right? Not only remember all of these topics, but also to see and put up practice that how can we actually do all of the things that are needed for UI. Okay, and again, this is using is React because at the end of the day, a lot of companies are actually using that. So far, so good. Mm-hmm. Exactly. This is now reducing rendering here. Parent components re-renders are child components. Parser gate. Words have meanings. Okay, okay. Parent components render child component. So pass down props. This one is just re-rendering because it is a child. Exactly. Exactly. Mm-hmm. Mm-hmm. Exactly. Exactly. Which is something that you can similar to a con. No, but that's one of the things that when you this is another thing when you want to avoid using context API. It's like extract the components inside of the GSX so you can now pass down data to that. No, no. No, because here what it's explaining is that is when again one of the an alternative to avoid is using a an alternative to not use context. So not only for passing down data, okay, but also when you want to pass down data to other components or to grandchild components, so you now put that parent component inside of that GSX, and then you now pass down that data to that, which is something that I know what he's talking about. But this is when you pass props like this, despite the ternary and child, that bottom component is no longer in the tree of that middle one. Pulling content up. project management kick in. Pulling content up with the children. Pulling content up with children. This is a technique to avoid use context to pass down data, which is this is a technique to avoid use context, to avoid using context to pass down data, which is extract is this one, by the way. You wanna know context? No. React.def is here like so. Escape hatches, that kind of thing. Is this one? Is this one? Is this one? Now I know I memorize this documentation and I love that. Context path through intermediate component. No. Exactly. Before using a component, extract components and pass GSS as children to this. Like so. So extract component and passing GSX as children. Sometimes you will want to nest your own components the same way, like this. This is just as a way to pass now down data for that. So extract a component, exactly, extract a component and pass the GSX as children to them. So for example, similar to this. You, my friend, you are overcomplicating stuff here, Steve, with your sense of, yeah, it's like I don't like your style, man. I don't like your style, but it's okay. Even though I don't like your style, give me what I want. Give me what I want. Period, man. Give me what I want. That's all. But the idea here is with this, specifically with this, is that it's pointing to this. It's pulling up control choosing, which is extract the component and pass the GSX element, okay, and then pass the GSX element, or then pass the GSS as children to them, and pass a GSX and pass a GSX children. Exactly. So extract the component and pass the data. And pass the data as a GSX element. What is it? And pass the data. And Jesus. And pass the data. And pass the data and pass GSX as children to them. Okay. Which is extract the component and pass the data by extracting the GSX as children. By extracting it as children to them. Why this? why is this? So for example, when you have now a list, and the using is a list for that purpose, you have the layout post. Okay, so instead of make layout children as props and render, you put that thing as it is. This reduces the number of layers between the component specifying the data and the one that it needs to. So for example, like this. So first, you may want to pass some data here. Okay, you may have some data to pass down to layout component or to a post component. But because that live inside of the layout like this, so what you do is to extract that component, the post, exactly, extract that component that you're going to pass down that data, as extract the components extract the component and pass extract the component and extract the component and the GSX and put GSX. Yeah, that's right. So extract the component and put GSX. So extract the component and pass the GSX as children to them by saying is this is the layout. Okay, I am not going to pass any data to you. In fact, I'm going to pass that data to the post, okay, as a list of posts. Okay, like so. Okay, so what do you is extract that component post and pass the GSX as children to them. So this is something that I'm quite familiar with this, because this reduces the number of layers between the component specifying the data and the one that needed. This, oh my god, no. This reduces the amount of layers you need to pass down from the component. Exactly. From the component specifying the data to the one that needs it. That's what you do it. Pass down from the component specifying the data to the one that it needs. That's exactly what you do. And I'm quite familiar with this. Yeah, it's not a stranger to me. I'm not a stranger to this. Maybe it's a So pulling content up exercise. So pulling content up exercise. PM came here and say, I love what you did. You want to write between the color write and the guessing, the color swatch and the guessing. Okay, but the sign team came, but the sign team needs to, they want to write in between the color and the swatch, but they want to write between the color and the watch. Okay, but they want to write in between the color swatch and guessing, but the design team needs to write between the color swatch and the guessing. No, but this is a warming. Okay. No. This is the warming application name badge. Hospital. Bounding box. Okay, what the heck is this? Clicker. Welcome callers. Coach need. Number use list. ED kits. Carousel. React base. React performance. API design. Application name batch. I think is. This one. But this time it is the inspirational color name batches, and this is now the warman. Okay, the warman repo. Initial slowdown exercise. Well, git clone here. Alright. And then you say list. Git, okay, cd warman. That's right. With 1,000 memos over time. And not having to render whenever say. Exactly, exactly. It's belong to the file where it's defined. But again, this is not pulling up content exercise, but this is this one. You check out pushing state down exercise. Okay, generate a random color here. Mm-hmm. Yeah, look, orientation expression function moved into a React component. There is nothing we can do about it. So here, let me actually install all the dependency here. npm star. Wait, what? This means that I have someone else running there. Not remember. I think it's color here. Yeah. Yeah, it is. All right. Exactly. Is this one? Jesus. Okay. Okay. So, So anytime we hit that button here with the generator random color here, we need to find a way to fix that, especially when we type inside of this, right? Because as you can see here, we can inspect this and take a look now at the, right now you're not able to see what I'm doing, but you will, and that is, take a look at this, all right? And then when I type here, is goddamn slow. It's horrifically slow. So what can we do here? Well, we can take now the profiler here. In particular, is in the components to see actually what is the structure here. Why is this so? That's right. So we got now the application, the color swatch. The gain input is actually the one that is causing this sloppiness. So by looking at our code and say, hey, the component gain input here is actually saying something like this. So when we are now passing down to that, okay, so anytime we are now calling this, or anytime we are updating this, or hitting the input here, and we're receiving this as props, and props here are the value and unchanged and unsubmit, as well as disable. Okay, we are receiving is all of this as props, exactly as a dictionary. So the question is that you're receiving this input props as like what? As the value? Okay, as the value, unchanged and unsubmit and disable. So the thing is that we are now calling is this function here. We're properly passing that states, and whenever it change, we're setting is the set color guess. So we are setting is a color guess here, which is, we're triggering is the set color guess, like this, set color guess. And the problem with that is that when they gain input here, uh, because this input is actually quite slow. Let me. Oh, okay. Oh, sorry. I'll be right back. I'll be right back. I'll be right back. And we're back. So for some reason, now this input is actually slow. It's very, very slow. So set correct answer here. Color swatch, which is we are passing down and all the tailwind here, followed by the gain input and game status, right? And as well as the expensive component. This is quite interesting because it's not here. It is when it's actually render this. So anytime, so you got now this block operation here. So anytime you actually is doing this, is like so. Because anytime you hit here, you are now passing in rendering all of those components per se. Okay, check out here like so, which is exactly right there. Can you refactor the component hierarchy to get the input field to be responsive again? So because here we got now this expensive component here, and we can say, hey, we can put it that right before here. Oh, really? But it's quite interesting. Not only that, because okay, rerun this. Okay. But it's because you also have this expensive component rendering here. Exactly. If there are any component that is blocking the main thread along the entire component hierarchy, it will impact the user experience. Especially if that component is now at the bottom of the if that component is performing some intense CPU tasks, so for example filtering thousands of elements and that kind of thing. So okay, it was hiding in plain sight. So for example, so when we're able to identify this kind of thing, as a way to set is the profiler, and say, hey, in this one, so what is actually the component that actually is causing that? Luckily for us, it's actually telling that 400 milliseconds render at render at 400 milliseconds is way too low. And this is quite interesting because now here is telling you which components actually is a slow down. So for example, if we remove that component, this is part of the heuristics. So for example, now if we remove that component, all right, for example, and then we clean that, and then we record that again, then we stop here. Now I'm gonna tell you that it's wholly, the difference is 100 times. Shit. Is 100 times. The difference now is 100 times for that. And most of the time, all of these components actually rendering is in this 0.6 milliseconds, 0.2 milliseconds, 0.1, 0.5. Then it render color swatch, then it render color input, and then is this. So this is something good to actually inspect that. And we take a look now at the performance here. For this, it's like, hey, I just want to now check the profiling here, right? We are not using GPU or network operations, okay? And it only is a way to use only most of the time you're idle and scripting. So, but the point here is that when you find yourself at bottlenecks and the kind of thing, you can start is with that particular recipe that I mentioned before. Initially with the production build, and then on the components hierarchy, and then it is a state. Inspect that, okay? Ask what will be the suspicion about it. Or ask what will be, what is the page when they actually detect that. And a good threshold is that if something is rendering, if something is taking 400 milliseconds to render, that's bad. 200 milliseconds, that's bad. 300, that's bad. 100, that's bad. Most of the time, those applications should render in 0.2546 milliseconds. Blazing fast. So it's like in this case, mm-hmm. Pushing a state down and then pulling the content up. So the idea here is that with that components that we don't care about that, because that what happened here is that so what it's doing is that this expensive component that is get rendered here, uh, since we don't want to actually make use of that component, okay, uh, we can extract that logic, we can extract all of that component into itself and all of the proper state to that components. So it's only those state at that particular position in the render tree and it's going to render that. And you don't care about this expensive component. So this is a very interesting way of how you can now reduce in rendering. Pushing state down. Pulling content up, but the other is pushing state down. Okay. So pushing state down. Yep. Pushing state down. So we get all of these states and pushing down into a particular components that are not alter the base class for that. Which is exactly what it's doing here. It's saying, hey, I'm going to create now a component called game.gsx. I'm going to call it here game.gsx. This will be now a, it's going to say cons game, that this is now a function, plain JavaScript function here. It's going to return now here a GSX element like div. Okay. And the idea here is that we're going to get is only the data or only the elements here. Okay, we're gonna get only the elements here. We say, hey, color swatch. That's right, as well as gain input, as well as gain status. The bottom, and then you got it, as well as the relevant state for that. We are pushing state down to that, which is taking in consideration all of this, right? And once you do this, all right, yeah, there's a missing curly bracket. Okay, and once you do this, this is now the uncontrolled component because it contains all of these relevant states. So we're not going to pass any data to this as props, not at all. In fact, we can get rid of this as well as all of the other. Generate random color is something that we use. So for example, the correct answer. Correct answer is there. Color swatch. Gain input. You think you are funny? All right. Generate random color. That's right. We also need the use state. Import that, please. There you got it. All right, and that's it. We need to export now this component here by saying export default the game. So now when we import this as game, using now this particular syntax as game, we are now being able to do that. Of course, here we're using this state, and there you got it. So now by doing this quick refactor, we say, hey, that's great, we are now rendering all of these elements. Perhaps we break up a quick the layout, but it actually is not performing as expected, even though that this is an expensive component, but it's not part of the rendering mechanism or the rendering system. So we now abstract that state and put it into or pushing down into another state component. Exactly. How he knows that component is getting re-rendered? Highlight updates when components render. Oh, this is pornographic. Highlight when components gets re-rendered. Oh my god. Okay. This is very, very interesting. Bye bye. Mm-hmm. It's not one size fits all, but mm-hmm. So tip two, which is that it's like push a state down to the proper component. Exactly. Tip one, push a state down to the proper component. So if a component, if an expensive component is rendering, if an expensive component, or you can say, by isolating that expensive component, or by isolating the other states into a component and pushing down the render tree. Okay, so by isolating those states and pushing down the render tree, you can, so you use React in a performant way. Mm-hmm. But it's like by isolating that state into a component and pushing down the render tree, you use React in a performant ways, avoiding re-rendering parts, avoiding re-rendering other parts of the render tree. It is the only thing that it needs you push it down. It is the only thing that it needed, you push that expensive component down. So if the only thing that it needed is the expensive component, you push that expensive component down. Yeah, the only thing is that so if the only thing that you need is an expensive component, you put that expensive components down. Mm-hmm. Or the only thing that doesn't need it, you put everyone else down. Or if you don't need that expensive component, you push everything else. You put everything else down. Interesting. Mm-hmm. So you separate bad apples from the rest. doesn't matter. Exactly, it doesn't matter. Mm-hmm. 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 Tip 2. Putting everything down in the tree is freeish. Using memo a lot is causing, it can slowly become a problem. It can slowly become a problem. Mm. We don't want the medicine to be worse than the disease. We don't want the medicine worse than the disease. Worse than the disease. Or worse. We don't want the medicine we don't want the medicine to be worse than the disease. Mm. Okay. Brooke Lieberman. Brooke Lieberman. from the remix. Okay. Broke Labyrinth. Interesting. Holy moly, it was a long time ago. Mm-hmm. Interesting. Very, very interesting. Mhm. Okay, so that'll be all for this video. Take care. Bye bye.